Today we will be discussing thermoregulation units, and the control of heating resistors in detail. We have discussed multiple times via this channel about temperature control units, heating systems utilizing electric heaters. But how to operate electric heaters? Typically, the control of resistors or heaters is assigned to an electronic thermostat, which, to maintain the set point accurately, activates the relay and thus the resistors at a specific frequency, ensuring precise temperature control. It is clear that if we have a frequency of intervention of resistors, therefore of the contactor, especially on electric resistors with significant powers, the contactor itself has a limited life, because clearly we all know that the contacts of a contactor have a useful life for which they have been designed. That is, they have a certain number of cycles beyond which the contacts deteriorate and the contactor needs to be replaced. What is the risk? The risk is not so much to replace the contactor. The risk is that this contactor gets stuck. That is, that the contacts weld together as a result of a prolonged series of operations over time and therefore no longer open and force the control unit to go into alarm because it reaches high temperature. Or what happens? The electronic thermostat calls for heat, closes relay contact, relay gets stuck. Thermostat says, okay, you have reached temperature, stop, but contacts do not disconnect and therefore resistance continues to heat. What's occurring? Clearly there are security systems, the safety thermostat intervenes, cutting off power and halting everything. Let's say nothing serious happens. The important thing is that the security systems are efficient. The temperature adjustment therefore has limits linked physically to the number of interventions that an electromechanical telethermostat can make. The solution is to install static relays. Static relays do not possess electromechanical contacts, but are controlled electronically. So we have the ability to make even tiny openings, tiny closures, and as a result, a temperature control system becomes inherently more precise and sophisticated. On the other hand, a solid-state relay could also be damaged, malfunction, remain closed, and therefore cause the control unit to exceed safety temperatures. Also, in this case, there is the safety thermostat that intervenes. For example, on our systems, we put a line contactor controlled by the safety thermostat. If temperatures exceed the limit, it cuts the voltage and puts the control unit in lock and safety. The further step forward in the search for increasingly precise temperature control is to use static SCR relays, that is, thyristors with adjustable power modulation. In this case, instead of using an on-off control of the thermostat, we could use power modulation. That is, modulate the power from a minimum to a maximum as if it were an inverter, but applied to resistors. Interesting, isn't it? Greetings. Thank you.